Bismillahirrahmanirrahim. Today I am gonna teach you question number 5, part 3, exercise number 2.4, differentiation. In question, differentiate this with respect to this term. So first of all, what we will do, we will suppose. Differentiate. How to differentiate? We first of all will suppose let y is equal to this term and z is equal to this term, and we name this as equation 1 and this as equation 2. Now first of all we will solve equation 1. Differentiate this term with respect to this term. It means we will differentiate y with respect to z. Differentiate y with respect to z. It means we want to find dy by dz. Differentiate this term with respect to this term, dy by dz. Basically we want to find dy by dz. Now first of all we will differentiate this term. Differentiate equation 1 with respect to, in the right side variable is x, so we will differentiate equation 1 with respect to x. Dy by dx. So we can see that variables are in the form by u by v, quotient. So we will apply a quotient rule. What does quotient rule say? According to quotient rule, derivative of any two variable quotient variable is equal to v derivative of u minus u derivative of v whole divided by v square. It means we consider this term as u and this term as v. So v, first of all we will write v is cx plus d derivative of u is ax plus b minus u is ax plus b derivative of v is cx plus d whole divided by v square. V is cx plus d whole square. Now cx plus d as it is, derivative of ax, derivative of a is constant, so we put a outside the derivative. Now derivative of x with respect to x is 1, so there is no need to write 1. Derivative of x with respect to x is 1 and a is constant, so we write as it is a, plus b is constant, so derivative of any constant is 0 and there is no need to write 0, minus ax plus b as it is. Now derivative of cx, c is constant, so we write c as it is, and derivative of x with respect to x is 1, so there is no need to write 1, and plus derivative of d is constant, so derivative of any constant is 0 and there is no need to write 0. So cx plus d whole square. Now what we will do? Multiply ca into cx, acx plus a into d, ad minus axc minus bc. acx and acx positive and negative cancel, and cx plus d whole square as it is. AD minus BC divided by cx plus d whole square, dy by dx. So now we'll differentiate equation 2. Differentiate equation 2. Here again variable is x. In the right side variable is x, so we will differentiate with respect to x. dz by dx. Now again variables are in the form of quotient, so we will apply u by v rule and u by v quotient rule. Quotient rule is v derivative of u. We consider this term as u and we consider this term as v. So v ax square plus b divided by ax square plus d, u and v. So v is ax square plus d derivative of u. U is ax square plus b minus u. U is ax square plus b derivative of v. V is ax square plus d whole divided by v square. V is ax square plus d whole square, v square. Now we'll solve ax square plus d as it is. Derivative of ax square. So derivative of ax square is constant, derivative of x square. Nx n minus 1 2x, 2 minus 1 becomes 2x and a as it is. So derivative of ax square is 2ax plus b. B is constant term and derivative of any constant is 0, minus ax square plus b as it is, and derivative of ax square similarly is 2ax, and plus d derivative of d. D is simple constant, derivative of any constant is 0. Ax square plus d whole square, dz by dx. Now we can see that 2ax and 2x is common from both the terms, so we'll take common. dz by dx is equal to 2ax is common. What is left? Ax square plus d minus ax square plus b. Ax square plus d minus ax square plus b whole divided by ax square plus d whole square. Now 2ax square plus d plus minus ax square minus plus minus b whole divided by ax square plus d whole square, dz by dx. Now ax square and minus a square cancel each other. What is left? 2ax into d minus b whole divided by ax square plus d whole square, dz by dx. Now basically we want to find dy by dz because we want to find differentiate this term with respect to this term. It means dy by dz. So we write dy by dz. Again we write dy by dz. So the other variable is x, so we put dx and dx. Here we put the value of dy by dx, and value of dy by dx is ad minus bc and divided by cx plus d whole square. ad minus bc divided by cx plus d whole square. Now dx by dz. This is dz by dx, so we invert it because this is dx by dz. This is dz by dx and this is dx by d. So we'll invert the whole term. This is in the numerator, this becomes in the numerator and this becomes in the denominator. Ax square plus d whole square divided by 2ax d minus b. So dy by dc. So multiply, but we will get a d minus bc and ax square plus d whole square divided whole square cx plus d whole square into 2ax into d minus b dy by d. It means we will differentiate y with respect to z. This is our required solution.